Hello, I will continue from this section the transformation of vectors from Cartesian to cylindrical coordinates. So in last section I just left it here, the cosine of angle between unit vector ax and arrow. So now you just see this figure showing the relative positions of base vectors. So here you can see here unit vector ax dot product of unit vector arrow is equal to 1 1 and cos phi, which is equal to cos phi, because here we are just taking the dot product of unit vector ax and arrow, which is equal to cos phi, because this is the cosine of angle. So we are getting here cos phi. Now similarly, unit vector ay dot product unit vector arrow is equal to 1 and cos of 90 minus phi, which is equal to sin phi, because here just you can see here ay is here, you can see that the unit vector ay and arrow here. So these dot product of these unit vectors is equal to cos of 90 minus phi. This angle is 90 minus phi, this angle is also 90 minus phi, this angle is phi and this angle is phi. So dot product is equal to cos of 90 minus phi, which is equal to sin phi. And now az unit vector az dot unit vector arrow, which is equal to cos 90 is equal to 0, because here we are just taking the dot product of unit vector az, you can see here unit vector az here and arrow, so which is this angle is 90 degree, so you will get this cos 90 and it is equal to 0. So now further the vector a phi is equal to unit vector ax dot unit vector a phi vector ax plus unit vector ay dot unit vector a phi vector ay plus unit vector az dot unit vector a phi vector az, and az is equal to unit vector ax unit vector az vector ax plus unit vector ay dot unit vector az vector ay plus unit vector az dot unit vector az vector az. So this is equation 6 and this is equation 7. So after this, the following this table can be used to find the dot products. So table for dot product of unit vectors, you can see here this is dot product unit vector ax, unit vector ay, unit vector az, and these are the unit vectors arrow, a phi and az. So unit vector ax dot unit vector arrow equal to cos phi, unit vector ay dot unit vector of arrow is equal to sin phi, and unit vector ay dot unit vector a phi is equal to cos phi, and this so same, you just have to dot product of these terms, you will get this one, then dot product of this one, you will get this term, dot product of this term, you will get this term. So similarly, ay unit vector a rho equal to sin phi, ay unit vector a phi equal to cos phi, and ay dot az equal to 0. We have already calculated all these terms here, you can find out here. So now unit vector az dot unit vector a rho equal to 0, unit vector az dot unit vector a phi equal to 0, and az dot az equal to 1. So this is the table for dot product of unit vectors. Now unit vector ax dot unit vector a rho is equal to cos phi, and unit vector ay dot unit vector a rho equal to sin phi, and unit vector az dot unit vector a rho is equal to 0. Similarly, we can obtain other dot products, which we will see in next talk.